In this video, we will discuss the second order energy. Oh no, we know the second order term is the h naught and psi n2 plus h dash and psi n1 is equal to E n naught and psi n2 plus E n1 and psi n1 plus E n2 and psi n0. Okay, this is the second order term. Now we can take the inner product. We take the inner product with the psi n naught. Okay, then this equation can be written as, then the psi n naught and then the h naught psi n2 plus psi n naught n2 h dash and psi n1 is equal to E naught n. This is constant, so they outside this, and then the psi n naught and the psi n2 plus E n1 and psi n naught and then the psi n1 and then h plus E n2 and then the psi n0 and the psi n0. Okay, this is equal to that. Now this inner product is similar to this. Okay, is the psi n naught steric, this one. Okay, this is the psi n naught steric, and then we can apply on this, then h naught and psi n2, and similarly for this term, this term, this term, and this term. Okay, we can write also this way. Okay, so you can remember this term also. Now where the h naught is Hermitian. Here h naught is only, this is a Hermitian. So then this term is, we can simplify is psi n naught and then h naught and psi n2 is equal to, we can simplify this separately, and then according to the Hermitian operator psi n naught, and here they apply on this, is then the psi n naught, this is also psi n. Okay, and then is equal to, when here apply on this, then they will get, this is psi 2 not 0. Okay, is E n naught and then the vocals is also, so we can write here, and then the psi n2. Okay, this is common, so we can outside the desk. Now we can put this term and this term. Okay, and the replace of this term and here, then E n naught and E n0 and E n2, we can write this equation plus, and then E n naught and h dash and psi n1 is equal to E n naught and psi n naught and psi n2 plus psi n1 and then psi n0 and psi n1 plus, according to the conical delta, using the normalization conditions, then this is equal to 1. So they can simply write En2. Okay, so this term is become cancelled to this term. Okay, so then we will get the psi n naught and h dash and psi n1 is equal to this one, En1 and psi n0 and psi n1 plus En2. So we can find this, the second energy order correction. So we can write this equation is the En1 and psi n0 and then the psi not this one, not this. So we can write first this term as the psi n0 and h dash and psi n1 minus, we can transfer this term to this side, and En1 and psi n0 and psi n1. Okay, now we know that the psi n1 is form a complete set is a linear combination of them, a linear combination, but only the n is not equal to n. Okay, and psi m naught. Okay, now we take the inner product with this psi n1 with the psi n naught, then the psi n naught and psi n1 is equal to the summation is not equal to n and cnn, and we take also here n naught and then psi n naught. Okay, this is equal to this. So here according to the orthogonal condition, this term is become 0. Okay, so this is equal to 0. When this is equal to 0, now this term is 0. Okay, this term is equal to this term and this term is equal to 0, so then this term is become 0. Okay, now En2 is equal to the En naught and h dash and psi n1. Okay, now we put here psi n2 and psi n0 and then h dash. Here we put the psi n1 value, this. Okay, so then summation, the m is not equal to n and the cnm and psi n naught. Okay, then we can this one is constant, so we outside the place, and this is equal to psi summation is n is not equal to n, and then psi n naught, and then h dash and psi n0. Okay, and also here this one. And now we can put the value of this constant we already find in the first order correction to the wave functions, and this is become equal to n is not equal to n, is equal to, first we write this term h dash psi n naught, and we put the value of this is equal to the psi n naught and h dash and psi n naught divided by psi n and e n naught, and that's one. Okay, now this term is the complex conjugate of this, so then we can write like this. We can write integration and psi static. This is a psi static. Okay, this term is becoming a psi static of this term, and then we can write the psi and dx for one dimension. So this is a complex conjugate like this one. Okay, so then we can write this equation is en2 is summation, the n is not equal to n, and psi n naught and h dash and psi n naught become a mod star, and divide by e n naught minus the e n naught. Okay, and this is the fundamental result of the second order perturbation theory. Okay, now you can remember this key point here. We explain, and this can also write like this. Okay, so this is similar to this case, and here the integration is not, there is solution. So this is similar to this one. Okay, in the next video we will discuss the degenerate perturbation theory. Okay, thank you.